Hello again, everyone. This is a supplement to imaginary numbers. There are like few things I wanted to talk about that I really didn't want to make the previous video any longer because it was long enough. Um, we talked about how to square and take the roots, square or cube or raise it to any power, really being high or low, last time by using the Moivre's theorem. Today, I want you to have a feel of the meaning of multiplication or division in imaginary numbers. I hope by understanding this, it would clarify the whole picture for you. And well, let's take an example and take it one step at a time. It's only one example I'm going to use, so you understand exactly what's going on. So let's say I have two um, complex numbers. So I'm going to call the first one Z1, and maybe I'm going to say it's 2 plus 4i or anything. It really doesn't matter. And then the second one, maybe you can use a different color. I'm going to say it's, should I? Let's see something. Z2, I'm going to make it say 5 minus 3i. And I want to multiply these two complex numbers. We learn how to do the multiplication, but I want you to look at it from a different perspective, from the perspective what's going on really here. So before I do anything, I'm going to find the argument r and the angle, let's call that theta 1. And here the argument, so I can, so let's call that r1 and theta 1. And this is, since it's z2, r2 and theta 2. R1 is the square root, like Pythagoras, 2 square plus 4 square. It's the square root of 4 plus 16. It's the square root of 20, but 20 is 4 times 5, so you can write it as 2 root 5. Here, it's the square root of 5 square plus negative 3 square equals the square root of 25 plus 9. It's root 34. We cannot simplify it anymore. The angle here is the angle whose tangent is y over x, right? That's what we did. If I can, yeah, let's draw it again. Okay, so as we said before, the horizontal is the real axis. Real. And the vertical, I think it's here. Well, you're not drawing to scale anyway. And this is the imagine. Okay. So the angle here, any angle theta, has a tangent of y, which is the imaginary, over x, which is the real. So it's arctan 4 over 2 for arctan 2. The angle whose tangent is 2. We know pi over 4 or 45 degrees, the tangent is 1. So this is more than 45, but we know that tan of 60 or pi over 3 is root 3. 2 is slightly more than 60 degrees, but we don't care, really. But notice that when the angle is positive, I'm turning counterclockwise. That's how we count. We say 0 if we are in degrees, 90, 180 to 70. So if I'm turning counterclockwise, that's positive. Well, let's find out here. This is the arctan of the y, which is negative, over the x, which is positive. Positive x, negative y, I'm in the fourth quadrant. So really, I'm going clockwise, which is negative. Maybe I should have written that in green. Okay, so what's the meaning of multiplying two complex numbers? If I look at the real portion, the R1, so the length of the new complex number or the argument would be R1 times R2, or 2 root 5 times. So R would equal R1, R2 equals 2 root 5 times square root of 34 equals 2 root 170. 170 is roughly 13. So the length of, or the argument of this guy is roughly 26, slightly more than 26. Why? Because the square root of 169 is 13. This is 170, so it's slightly more than 13 times 2 would be slightly more than 26. So I took a line that's length is roughly 26 on the real axis. I turn it by an angle more than 60 degrees clockwise, and then I turn it back with an angle of roughly 30 degrees clockwise. So that's the geometric representation of what we have. And we can easily find it by saying I already found the length, and now I can find the angle. The angle theta would be theta 1 plus theta 2, but theta 2 is negative, right? It's a negative angle. So I'm going to say theta equals arctan 2 minus, oops, arctan, or atan. I wrote this 10 inverse, so anyway, of 0.6. I am on radian, so I'm going to say arctan 2 minus arctan 0.6. I get the angle is 0.5667 radian. If you want, you can multiply it by 180 and divide by pi to get a feel. This is like 32.47 degrees. Remember, we said we are going to go more than 60, slightly more than 60, because 2 is more than 1.73, which is root 3. And then I go back root 3 over 3, which is roughly 0.5. I'm sorry, root 3. Yeah, we said root 3 over 3 is 30 degrees, but root 3 over 3 is slightly less than that. So I go more than 30 degrees. I go more than 60 here, more than 30 there, and I end up with 32 and a half. So it makes sense. So now I can write the result R as either 2 root 170 times e to the I theta, 0.5667 which is basically 2 root 170 times cosine 0.5667 plus I sine 0.5667. Let's do that with a calculator and see what we get. So 2 square root of 170, open parentheses, cosine this angle. No, I should have. Did we open parentheses? Yeah, I think I opened parentheses. Okay. So close the parentheses plus I sine of this angle, close parentheses, close the big parentheses. So I get 22 plus 14i. And that's basically z, which is z1 times z2. This is r, so this is z. Z, which is z1 times z2, is this. Try it and see for yourself. 2 plus 4i times 5 minus 3i. 2 times 5 is 10. 5 times 4i is 20i. Negative 3i times 2 is negative 6i. And negative 3 times 4 is negative 12, but I squared is negative, so you get positive 12. Add them up. 10 plus 12 is 22. 20 minus 6 is 14i. Same result. But now we understand that if I have two vectors, I take their length. I keep saying vectors. Two complex numbers because vectors work similarly, very, very close to that. So I take two complex numbers, find their arguments, multiply them together, and because each one of them has a magnitude more than one, it's like I'm taking a vector, a complex number, with argument 2 root 5 or root 20, and then multiplying, meaning extending it by a factor of root 34. Or I take a complex number of length root 34 and extended that by a factor of 2 root 5. I look at this angle, y is more than x, so I turn counterclockwise, a distance or an angle of arctan 2, and then I go back an angle of arctan 0.6. So you see now multiplication, division would be the exact opposite. I divide this by that, so it's or let's say I divide this by that. So I'm dividing root 34 by root 20. So root 1.7 would be the length of the resulting complex number. And then I went clockwise and I divided, so I got clockwise again. You see that? If you divide this by that, you already went clockwise in the fourth quadrant. And then when you divide, notice when we multiplied, we added the angle. When we divide, we subtract the angle. So the angle would be negative 2.6. Arctan negative 2.6. Or negative 2, I'm sorry, arctan negative 2, let's say, and then minus arctan 0.6, negative points. I said negative, so 0.6. Okay, so that's the angle I turn, and the r here would be root 34 over root 20, which is root 1.7. Let's try that. Just I didn't expect to do this, but let's assume. So I'm going to say arctan negative 0.6 minus arctan 2 equals. So here is the angle. So to find this angle, or to find z, or z, let's call it z3, which is z2 divided by z1, that's what we did, would be the square root of 1.7, remember 34 over 20, times cosine this angle plus I sine this angle. I get negative 0.1 minus 1.3i. Let me check that for you. So we divided 5 minus 3i by 2 plus 4i. So we have to multiply by 2 minus 4i, 2 minus 4i. The denominator, remember we said when we get that, you square the 2, you square the 4, and add them up, so you get 20. Then the numerator, you get 5 times 2 is 10, 5 times negative 4i is negative 20i. 2 times negative 3 is negative 6i, and negative times negative is positive, and I squared is negative, so minus 12. So you get negative 12 minus 26i. Well, if I divide negative 12, no, I don't get that. Something went wrong. So I should get, did I do the math correctly? 5 times 2 is 10. Yeah, this is negative 2, not negative 2, not negative 12. Why did I say 10 minus 12 is negative 12? I have to watch some videos to learn how to add and subtract. Oh my God. So negative 2 over 20 is negative 0.1, minus 26 over 20 is 2.6 over 2, or 1.3i. Oops, exactly what we had here. I thought when I was solving this is that, division is the exact opposite. So let me use the same two complex numbers to explain the multiplication. Is that you are inflating, if the argument is more than one, you are inflating or extending the length of the complex number. If it's less than one, you are shrinking it. Or if you are dividing by a complex number whose argument is more than one, you are shrinking. If you are dividing by a complex number that has an argument less than one, you are extending or stretching. Same thing. Turning clockwise is positive, turning counterclockwise is negative in multiplication. But if you are dividing by a positive angle, you are going clockwise. And if you are dividing by a negative angle, you are going clockwise, because it's the opposite of multiplication. Again, I hope that wasn't so bad. I hope you learn now what's the meaning of multiplication, division in terms of rotation or shrinking, which is very similar, or it should be very intuitive to you. Again, finally, if you have any questions, I will be glad to answer them for you. Thanks for your time. Hope to see you soon.